just got to my destination. So first of all, I want to make sure that everything is working. I see we're just getting our technology set up. Hang on a moment. We'll be here soon. Oh, good. So now I see me. Great. So I think we should be in shape now. Let me double check one thing. I just want to make sure that I have the right chat system here. Okay. Well, let's go ahead and do this. Great. Well, nice to see you guys. I'm going to hope that you guys can hear me. I'll ask our tech support people, could you please send me a message in our system on the right the right chat relay room and password, because then I can go and put the chat on my screen too. I actually don't have that on my screen right now because we have a couple of different shows which are happening at the same time, and so it's actually different for our different shows. But regardless, welcome to our live cell. Oh, just a second. Not able to do the chat relay thing. That's actually because I think the main issue of why it's not appearing on my, oh, yes, great. Okay, good. My team just sent me something. Our team is awesome. Just a second. Let's do this. And then, does this work? No. Oh, good. It is working. Good, good, good. You guys are here. All right. Well, welcome everybody. So you can see now that when you send messages to Chat Relay, they pop into here. If you're not able to do it, just try to choose to send a message to Chat Relay. It should work because I see things coming through already. Don't send them to me. It won't help. If you send them to me, they won't appear here. But anything you send to Chat Relay comes down here. So this is good. We're here and the system works. Great. Welcome, everybody. Again, sorry for the delay. I'm here from Oklahoma right now. I just finished running the Putnam Math Competition thing back at Carnegie Mellon University, so my semester is over, and that means I'm traveling around the world. But we still consider that doing these live solves is a very high priority, and so it's a real pleasure to be here doing an official collaboration again with Math Kangaroo USA. Now, usually we have somebody from Math Kangaroo who's also around. I want to know, I see Jonathan Tam is already inside our Zoom here somewhere. Oh, yes. And you also, I just saw your camera. So
Yep.
what I'm going
Hi.
to do, what we always do, is that I always say a little bit of a welcome, and I also introduce our Math Kangaroo visitor. And after that, I'll also point out our two live instructors who are going to be running the rest of the show here. I do want to welcome everybody to our show. We're very pleased that every single month we do this collaboration with Math Kangaroo USA because we think that the questions are really creative. This happens to be the grade 3, 4, 5 room, and for basically everyone that I meet whose kids are in elementary school, whenever they're asking me, what should I do for math for my kids? I tell them, don't just do a whole bunch of calculation. No, go find the Math Kangaroo old problems for elementary school. I think that they're great because there's so much that you can learn from thinking about math instead of just doing calculation. And we're so happy to have an official representative from Math Kangaroo USA in this room as well. What's going to happen next is I'm going to pass it to Jonathan. I'm going to introduce Jonathan, then I'll pass it to Jonathan, and then Leo and Joe will take over from here and introduce each other. They are our stars of the show. But about Jonathan, well, Jonathan comes in from Silicon Valley, and he uses math in real life. He works as an electrical engineer, specializes in the design and development of radio frequency integrated circuits and wireless solutions. I wonder if that has something to do with, well, I guess basically everything that we have today, because we don't really use wires for most of the things that we do. And he is also the parent of two children in elementary school, both of which have participated in Math Kangaroo, and he is a passionate math ambassador and certified and credentialed teacher and coach. And this is the third year that Jonathan has served as Math Kangaroo Site Manager. And more recently, he was involved in the inaugural launch of the Math Kangaroo Team Competition, which is actually quite an innovation. With his experience in industry paired with his passion for teaching, Jonathan strives to create opportunities for students of all abilities to enjoy, explore, and exercise their creativity while solving interesting, relatable, and real-world mathematical problems. With that, Jonathan's going to give a welcome from Math Kangaroo and then pass to Joe and Leo. And I'm going to drop off because I'm going to run to our other Math Kangaroo room.
Great.
Nice
Are
to see
you
you,
all able
Jonathan.
to hear me, though, first of all?
We all hear you. We all hear you.
Great. Okay. Thank you for the warm
Okay.
introduction. Okay. Thank you. I'm So once again, thank you, Po-shen, for introducing me. I'm so thrilled to be here on your live stream today representing Math Kangaroo and sharing our mission, which is making math fun, accessible, and solvable for everyone, regardless of age, background, or abilities. So when students take part in Math Kangaroo, they're not just solving problems, they're building skills that last a lifetime. Problem solving, logical reasoning, and critical thinking. These are all tools that empower the next generation of innovators and difference makers. So for nearly 30 years, Math Kangaroo has been doing exactly that. Over 300,000 kindergarten through 12 students in the US and more than 6 million students worldwide have joined in this incredible journey. So if you're ready to challenge your math skills, make sure to sign up for the Math Kangaroo 2026 individual competition. It happens every year on the third Thursday of March. So mark your calendars for March 19th, 2026. You'll tackle 24 to 30 fun and thought-provoking problems and compete with students across the whole nation. The top performers win prizes. Of course, all students love prizes, such as, let's see here, I have medals. This one here is a first place medal. I don't know if you can see it. You can win ribbons if you rank in the top 3 for your state. And you can get toys or plushies. And I think this year might be plushie. I'm not sure, but this is my favorite one. I think this is an all-time popular item. And if you place in the top 20, your name could be featured on our website for the world to see. So registration for the individual competition is open now and closes on December 31st. That's just really 24 days away. So don't wait because the test centers fill up pretty quickly. You'll want to register really soon. Now, you might be wondering why I highlighted that the March competition is an individual competition, because this year we launched something brand new, our first ever team competition, which took place just 2 weeks ago. Since it was our pilot year, we weren't sure what to expect, but the response just completely blew us away. We had 594 teams to tackle who jumped in to tackle 24 to 30 kangaroo style problems in a 60-minute contest. The feedback so far has been just incredible from students, coaches, parents, and even my own children. 100% of the respondents say that they would do this again next year. And here's the best part. It wasn't just about math. It was about teamwork, collaboration, and learning how to turn disagreements into solutions. As an engineer in industry, a teacher, and a parent, I can tell you wholeheartedly that this experience is priceless. So keep an eye out for the 2026 team competition. You definitely won't want to miss that next year. If you want to find out more about this growing event, please email Math Kangaroo for more information. So thanks again for having me. I'm so excited about what's ahead, and I look forward to working together as we continue this amazing journey. So back to you for the LiveSolve team.
Oh, hi. I think Professor Lowe is gone, right? Is that right, Joe? Um,
Oh, I was unmuted the whole time, so you couldn't hear what I was saying.
that's all
Apologies
right.
for that. Um, let's see. Here we have, we'll introduce each other. Leo. Leo is a high school junior in Seattle, Washington. He does AMC yearly, achieved DHR in 7th grade, and qualified for Amy since 9th grade. He got second at his local UW Math Hour Olympiad twice. Besides math, he plays on his high school's frisbee team and coaches the middle school team. He is the captain of his school's quiz bowl team, and he specializes in history questions. He enjoys biking Seattle streets and paths, as well as folding modular origami.
All correct, yes. And I'm here today with Joe Li, junior from Maryland, who's been doing competitive math since elementary school. He's qualified for Amy 3 times and enjoys competing in both math and physics Olympiads. He is also the tournament chair for his Mu Alpha Theta chapter and the captain of the school math team. Outside of this, he likes to play varsity tennis, the cello, build fun contraptions, and play turn-based strategy games. So, a warm welcome to Joe.
Warm welcome to Leo as well. To get us started tonight, let's start with something a bit less formal. Let's have a bit of an icebreaker, so we can get to know all of you better. So, what is your favorite holiday-themed song? Put your responses in the chat. We can actually read the chat. So yes, hello. We can see all of you saying hello to us, which is very nice.
So as you're coming in, you can use this as a practice of typing to chat relay. So I see very, very few people are sending messages specifically to me. I don't know about you, Joe, but it seems like people are picking up the chat relay thing really quickly.
Yes, I'm seeing a few messages in my Zoom chat. For the Zoom chat thing, please send a direct message to chat relay, and then your message will appear right here. If you send your message directly to me, I can't really read it because that my text app doesn't allow me to. So if you want to talk, please type to chat relay so you can so we can see it here. Yes. Yes. Hello. Okay. Yeah, I'm seeing a lot of Christmas songs, a lot of that stuff. Yeah, I think what better what better present that we can give than our lovely life solve? You want to start with the problems, Leo?
Yeah. Let's get to the first problem. So first we've got kind of a rope-based problem, and the question is, which rope ties into a knot when the ends are pulled?
Yeah.
Okay, take a moment to think about that one.
Yeah. I mean, just spitballing here. I mean, I think we can start by eliminating a few of these. For example, let's say A. I think A, when you pull it, the string is just piled up on itself. So it's probably not A, because that won't make a loop. Can you guys think of any other rope arrangement that could be similarly eliminated like this, where the rope is just stacked on each other? Yeah, put it in the chat. What other ropes could we eliminate using this method?
I see a lot of people saying B. What do you think about B?
Yeah, I mean, it's similar to A. I mean, the little end on one of the little ends is a bit under, but I mean, if you pull it out, it's still kind of just stacked on each other. So it's probably not B either.
Okay.
Yeah. I see a lot of people saying D as well. What do you think about that, Leo?
I think D is really similar to A. If you pull on both ends, yeah, it's just like a spool, kind of. It's not a knot. So we can also eliminate D.
Yeah. So now we're just left with C and E. Any ideas on which one we can eliminate next, Leo?
I'm seeing a lot of people in the chat saying both C and E. So I think this is kind of a tough one, but and this is kind of a hard thing to explain out loud, but if you kind of just look at it, you can tell that E would produce a knot, whereas C would not produce a knot.
Yeah, I mean, when you pull on C, I mean, it's not really a knot, rather than like a bit of a loop around a thing. Like if you pull around it, this little loop, oops, let's see. Yeah, if you pull on it, it doesn't really make a knot. So we can also eliminate C. Yes, and as we can see in the chat, a lot of people are putting E. Yes, this person put 5 E's. That's how confident they are it is E. And yeah, what do you think, Leo?
Yeah, I think E's the correct answer. Shall we check?
Yeah, let's check.
All right. Yeah, you can kind of see right up here, the answer is indeed E.
Yes.
So after we solve a problem, we can see the answer up here. If you're curious where it came from, you can also see that right here. So this one came from the 2025 test for grades 3 and 4, and it was problem number 3.
Yes. Yeah, I mean, great job, you guys in the chat. Y'all are great. Let's see. You want to move on to the next problem, Leo?
Let's do it.
All right. Oh. Ooh, I seem to have disappeared. Hold on. Let me undisappear myself. Aha, okay. I think
Okay,
both of
we're
us are
back.
back.
Oh,
Ooh,
you're
I'm
disappearing.
gone again.
I think
It's okay. we can figure these out while we read the problem. Leo, would you like to do the honors?
Sure. So the problem is, on a regular die, the total number of dots on two opposite faces is always 7. Which one of the dice shown below can be a regular die? And I'm seeing immediately in the chat that the answer could not be C. And why is this? Can anyone... I see in the chat we have 6 and 1 are opposite, like 3 and 4 and 2 and 5. So for for option choice C, we've got 1 and 6 both visible, so it can't be a real die. Does that make sense, Joe?
Yeah. I mean, there's only like one of each number from 1 through 6. So if we've already used the 1 somewhere else, then we can't have it on the other side of the 6.
Yes.
Yeah. So we can pretty safely eliminate C.
Okay.
Yeah. And I think we can apply this same logic to some other dice too, don't you think, Leo? Yeah, what other dice can we apply to... Oh, sorry.
Yeah. I was just going to say, people in the chat are screaming that it cannot be B. And I think that's because we can see both the 2 and the 5. Therefore, B could not be regular.
Yeah. Checks out. What are other ideas you have? Oh, I see someone who says E also has this exact same problem where you have the 2 and the 5. They're both shown, so they can't be opposites.
All
Yes.
right. And then A or D?
Yeah.
Let's see. The answer is, okay, I'm seeing probably 23 A's from somebody. Wow, we are really confident that it is A. And that makes sense because D has both the 3 and the 4 visible.
Yeah.
And therefore they can't be opposite each other. So it can't be D, and it must be A.
Yeah. So that seems about right. Should we check the answers?
Let's go for it.
Let's see. It is A.
Exactly right. Good job, chat.
Excellent job, chat. Let's move on to the next problem. Okay. Kenny the kangaroo jumps from the school to the zoo as follows. 2 up, 2 to the up left, 1 to the down left, and then 4 to the left, as shown as a picture. Then he jumps from the zoo as follows. 3 to the right, 2 to the upright, and 2 up. Which house will he get to? And we have all the little drawings of the houses here. Let's see. Let's get a larger diagram here. So, I think we have to go step by step here. Let's see. After the first 3 right, where do you think he'll arrive?
He starts from the zoo, is that correct?
Yes, the zoo, all the way on the left over here.
Okay, so let's just follow his path. So 1, 2, 3. And I've shown in purple that, is it Joey?
Yeah, Kenny the kangaroo.
Oh, Kenny. Joey would have been another name for a kangaroo. Anyway, Kenny is right where I have this purple dot. The next step is to go 2 up and to the right. So where would Kenny end up after that?
Yeah, I mean 2, so each upright step looks like it goes 1 diagonal, as we can see from this part over here, when he was going to the zoo. So I think we should just have 2 of those. What do you think, Leo?
Yeah. Okay, so those are the 2 steps I've drawn in purple, and then Kenny would end up where I have this yellow spot now, okay? And then, Joe, do you remember what the last step is?
Yeah, I think it goes 2 units up. So, I mean, we can just draw that with the same logic we've used before. And I can see the chat. Everyone is spamming A. I mean, that is a lot of A's right there. That's got to be at least like 30. And if we just go up twice, we reach this house. which, as everyone is saying, this is house A, I'm pretty sure. It's got the 2 round windows and the red hat. Right? What do you think,
Yeah.
Leo?
Yeah. This is house A, and it kind of looks like a duckling face, maybe.
Mm.
I don't know exactly. Something like that, I'd say.
Yeah, it's got like the yellow duckling color, and it's got like a kind of a beak in front. Yeah. Okay. Let's check the official answers. It's A.
Answer A. All right. Fantastic job, chat. Let's go to the next question. And Joe, do you want to read this one?
All right. In the morning, 5 friends had identical, fully charged mobile phones. By the evening, Bob had spoken on the phone as much as Anne and Christina together. Bob ran out of power. David had not used his phone at all. Which phone belonged to Edward? How do you think we should start here, Leo?
I think, like a lot of the other problems, we should use process of elimination. So, chat, which phone must have belonged to David? It says David did not use his phone at all.
Yeah.
Okay, I'm seeing people are saying 1 in the chat. 1 is David. Okay, that makes sense, because if David didn't use his phone at all, it would be full battery. So we can eliminate David for this problem, right?
Yes.
Or we can eliminate phone number 1.
Yes. And I'll mark it with a D right here for David.
Good idea.
Let's see. What other information can we immediately eliminate? For example, how much phone battery does Bob have left? Yeah.
In the problem statement, it says Bob ran out of power. So, yeah, the chat predicted my question. People are saying 3 is Bob. So let's mark that.
Yeah. And now, the only people left are Anne, Christina, and Edward. And the only piece of information that we haven't used yet, in these problems, it's good to see which pieces of information you haven't used yet to see where we can go next, is that Bob had spoken as much as Anne and Christina together. So that means that the amount of power that Anne and Christina used must have been equal to Bob. Where do you think we can go with this, Leo?
Well, Bob used all of his power. So that means Anne and Christina's amount of power loss should add up to a full power bar of power. So do you think that Anne and Christina could be 2 and 4, for example? Does that make sense?
I mean, if we take 2 and 4, if we look at the white gaps parts, they don't add up to a full battery. Yeah, put in the chat which ones you think are Anne and Christina. Yeah.
Okay. A lot
I
of
see.
people saying, I said Daniel put 4 and 5. Joe, do you think that's right? A lot of people are agreeing in the chat.
Yeah. If they're 4 and 5, then this used part plus this used part, they look like they add up to about a full battery. So I think one of these is Anne and one of these is Christina.
Right. And we don't know exactly which is which, but that's unimportant for this problem. Because we're using process of elimination, neither of these could have been Edward's phone. And that leaves one phone remaining, which is
phone number 2.
Exactly. So the answer should be B or 2. Shall we check the answer?
Let's go for it.
All right. Here it is. Answer is B, 2. So chat with 100% accuracy today so far.
Oh yeah. Let's see if we can keep it up. Let's see. Next problem. Would you like to do the honors this time, Leo?
I'll do it. Maria fills the circles with the numbers 1, 2, 3, 4, 5, 6, and 7. The number in each of the lower circles is equal to the sum of the 2 numbers in the connected circles above it. What number goes in the circle with a star? It does not seem like we have very much information on this one.
Yeah.
So how do you think we could get started? Maybe the chat could give us some helpful tips. Any ideas?
What numbers could we fill in immediately?
I see Anand says 7 is the first one. And I think what they mean by this is that we must have 7 here. This is a great insight because no other number could be the sum of 6 and something else, right?
Yeah. I mean, we only have so many numbers, and 7 is the only one that's bigger than 6. And if the number below it has to equal the 2 numbers above it, that means the only number that can go here is 7, because it's the only one bigger than 6.
Yeah, yeah.
Where can we go?
Yeah. Joe, do you know what goes up and to the right of 7 then? What plus 6 equals 7?
Yeah. Oh, I'm seeing in the chat that they are saying 1, and I am in agreement. I think that 1 should go in there.
All right. Let's fill it in.
All right. Let's see. Where can we go after this? I see that in the chat. Leo, where do you think we can go from here?
Let's look at the numbers we have left. And remember, we have pretty big numbers on the bottom, usually, and smaller numbers up top. Which number could we have as the sum of 2 other numbers? And let's remember which numbers we have left. We've got 2, 3, 4, 5, right? So how could we add 2 of these together to get a third one of these? I can see 2 ways for this to work. Oh wait, no,
Yeah.
I can only see 1 way for this to work, actually.
Yeah. I mean, let's focus on this group of 3 over here first. I mean, we need to choose 2 of these numbers from 2, 3, and 5, and then add them together to make a third number. So, which number has to be in the bottom of this group of 3 I've marked over here?
Yeah, Haley says 5? Yeah, you're correct. It has to be 5. And I see the 2 numbers adding up to 5 would have to be 2 and 3. So how about we fill that in? But Joe, which of 2 and 3 goes on the left and which goes on the right?
We have to do a bit more deep thinking for this, because we know that, well, now the only numbers we have left are 2, 3, and 4. And we know that since one of these is 2 and one of these is 3, although we don't know which one yet, one of these top ones, we know that 4 must not be either of them, so we can actually fill in another way.
Oh yeah, so we could put 4 in the star location, and then working backwards, we know it must have been 3 plus 1 that added to 4. And then we can place the 2 in the top right corner.
Yeah. And let's see what the question's asking for. What number goes into the starred circle? Well, I mean, we have it right there. Should be C.
Okay, should we check the answer?
I think we should.
All right, yeah. Again, correct. The answer is 4, or answer choice C.
All right.
Okay.
Let's move.
These problems are kind of ramping up in difficulty. This one was problem 15. I don't know what the next one is, but Joe, would you like to read it?
Yeah, sure. Zoe built a pyramid using black and gray cubes. She arranged each cube so that each face does not touch the face of another cube with the same color. One of the black cubes is shown in the picture. What does Zoe's pyramid look like from above? Let's see. We have black and gray cubes. Where do you think we should start with this, Leo?
I don't know. I want to hear some ideas from the chat.
Yeah. Where do you think we can start this problem? Hmm. Let's see.
Hmm. Well, okay, I do have an idea. We can see that we already have this white cube, right? This one that's already shown in the diagram.
Yeah.
So we can already show that the two touching it have to be black. That's
Hmm.
part of the problem, that cubes of the same color can't touch, right?
Yeah.
Okay, so let's fill that in. And in place of black, I'll use purple. I think Joe is using blue.
Hmm.
And I think that means we also have two more that we can fill in immediately, right?
Yeah. I mean, since the black cubes can't be next to the gray cubes also can't be next to the black cubes. And so we can label the other two next to the ones we just labeled, and we can say that they're the other color. So I'm
Right,
going
yeah.
to shade them in with red, because gray doesn't really show up well on my display.
Uh, I think I've been confused about the colors, but it should be a pattern like I
Oh,
have. And am I uh Joe, don't these colors match? Don't we have, it says one of the black cubes is shown, and they've shown the black cube in white. Is that right?
yes.
Okay, I feel like
Um,
that's a little confusing, but
yeah, I'm
you
not sure if our
do what you
colors
can.
are just mixed up. But, I mean, we can already let's keep going. I mean, there aren't really reversed patterns, so if we just find the whole pattern, I think we can figure it out.
Okay, how can we continue the pattern from here?
Yeah. Hmm. Let's see. Put your ideas on how we can continue the problem right here.
If you already know the answer, that's less helpful. Uh, but giving us some technique would be more useful.
Yeah. I mean, let's think. The pyramid is built, so there must be under this block that's I've shaded in blue and Leo has shaded in purple. Underneath that block right there, it must be a block of the other color. So like if we like think about the block under this block that I'm pointing at right now, that one must be another color, which means that since that color is white as we have indicated it, that means this one, which is next to the one under it, must be blue as I've labeled it. Right? Where do you think?
I'm not sure. I don't know if the problem says that, but well, what if we just looked at the answer choices? How about this? Uh, let's take a look at the answer choices and see if there's any we can eliminate because they would not be possible.
Hmm.
So, for example, answer choice C, does that work? Because I can I have, and this is a little bit hard to indicate on the drawing, but I am circling two squares that would be next to each other. These right here, these would be next to each other, but you shouldn't be able to see, like they shouldn't be, right? Because they would be touching.
Hmm. Yeah. I mean, it's trying to look at what it looks like from above. So yeah, I mean, you can't have the same color next to each other in the 2D plane, but maybe if we're looking in the 3D plane, it might be still possible. I don't know though, yet. Yeah, it's a 3D plane that's built up with blocks. So I'm not sure. What do you think, Leo?
I also like your technique. If we can't eliminate things, let's try and figure out some. So I'll also fill in what you've discovered on my screen, that we have to have, or what I have is purple here, and similarly over on the far left as well.
Yeah. Hmm. Let's see.
And
Let's
because
try
of
to.
adjacency, we can also fill in a few more squares or a few more cubes, and I kind of like I'm doing right now.
Yeah. We can use the same logic that like the square underneath of this square that I have a white arrow drawn to, the square underneath has to be blue. And if that's blue, that means the square next to it, which is the square I'm shading in right now, has to be white. Or whatever color they've used in the problem. It doesn't show up well on my screen, so I actually can't tell. But if we fill all of these in, we can get a better idea of what the final answer might be. And this one we can actually fill in with blue. Let's repeat this process for the blocks that are above.
Yeah. So kind of like this cascading or climbing upstairs problem technique, we can fill in this square on my screen, this like center one kind of diagonally up from another one of your blues, and we can fill that as blue as well. And the ones next to it have to be white.
And finally, if we look at the top square cube, it also has to be white by the same logic. So let's look at our answer choices right now. If we look at it from above, I mean if we have like a 4x4 square, 4x4 grid, we can see that the top layer has to be white, and then blue or purple, then white, and then blue/purple. And there's only one answer choice that goes with this. Which one do you think it is, Leo?
Yeah, it's this one I've circled on my screen, which is option choice D.
Yes. Let's see if that's the correct answer.
Yes, it is the correct answer.
Nice. All right. Let's move on to the. That was a long problem, you know.
Yeah.
Yeah. Let's move on to the next one. Would you like to do the honors of reading this time?
Yeah, this is kind of a wordy problem, so bear with me. Okay. Anya wrote down the number of pieces of different fruit that she has. Unfortunately, some digits have been covered by paint. In total, she has 106 pieces of fruit. The number of pieces of 2 of the types of fruit are equal. She has twice as many of one type of fruit as she does of the other type. She has more than 10 pieces of each type of fruit. How many bananas does she have?
Well, that's a pretty long, wordy problem. Where do you think we can start by getting useful information from here?
I like this. 2 of them are the same. Chat, if 2 of them are the same, which 2 do you think are the same? Hint, look at the last digits.
Oh.
Yeah, I'm seeing a lot of people saying apples and oranges. Because we have the same last digit for only these 2, it means that these 2 are the only ones that can be the same. So we can use that fact right now. So there are 30 apples, 30 oranges. What else do you see, Joe?
Well, I see that she has twice as many of one type of fruit as she does of one other type. Is there anything useful we can get out of that information, do you think?
Hint, you can look at the last digit again.
Yeah. Let's see.
I haven't
Put
seen
your ideas in the chat.
I haven't seen the correct answer yet. Oh, I see pears times 2 equals mangoes.
Yeah.
Okay. I like that because 2 is twice as much as 1, and the units digits kind of give it away here. So that means mangoes has to be twice as many as pears.
Yeah.
But how many exactly would that be? I can't really tell yet.
Yeah. Me neither. Well, but we know that since we're doubling it, let's let the first digit of the pairs be x. And we know we can set a variable. We know that the first digit of mangoes has to be 2x. And there's only one piece of information besides the 106 that we haven't used yet, and that's that she has more than 10 pieces of each type of fruit. So, I mean, if we choose a too large of a number for x, then we won't have enough fruits left for bananas. So let's start by adding them all up, and let's see where we go from there.
Okay, so in the ones place, I have 2 plus 1 plus 3 equals 6. So that makes sense. And let's also do how many groups of 10 fruit we have. We've got 2x times 10 mangoes in the 10. So 2x plus 3 for the apples, plus x for the pears, plus I don't know how many for the bananas, plus 3 for the oranges. And let's also say there's some number of bananas. This has to equal 10.
Well, let's see. Where can we go from here? Well, we can simplify this a bit. We can get 3x plus b equals 4. And we have to remember that since she has at least 10 pieces of each type of fruit, both x and b have to be at least 1. And I think there's only one combination of x and b that fits into here. What do you think, Leo?
Yeah, I think, and I also saw this in the chat already, we have to have x and b are both equal to 1. So if we fill in 1 here, that means 13 bananas. And that is answer choice A. So what do you think? Should we check the answer?
I think we should. I mean, the chat's been yelling at us that the answer is A for so long. And I trust the chat. The chat's been right almost all the time.
Okay, let's look. Yes, it is indeed 13.
All right. The chat is proven to be correct once again. Let's move on to the next problem. All right.
Ooh,
Which of the
problem?
These are interesting. Pattern recognition is a very important skill. Which of the pieces would complete the pattern? Well, let's look at this in a larger screen. Yes. Well, let's see. What parts of the pattern can we look at first? Well, let's look at the corners of the pattern first. What do we know about the corners of the pattern? Put your ideas in the chat. Or yeah, what has to be in the corners of the missing part so that it fulfills the pattern?
Yeah, and maybe something more helpful than just giving the correct answer. We don't just want to know the answer, we also want to know how we get to the answer.
Yeah.
Okay, I saw it from Evie and B. They said squares. I think this is because they're these squares that kind of appear on the screen. Like, here is a square, here's another square, here's a square. There's a bunch of squares all over here. And if the pattern continues, we have to have a square here. So I'm going to fill in these 4 corner squares. And then let's see which answer choices are still possible. Okay, so chat, which answer choices no longer match what we've already filled in? And they are A, B, C, D, E from left to right. I'm seeing a lot of people say D and E. Joe, do you agree that D and E are impossible now?
Yeah, because they don't have this little box in the corners that indicates the square corner, so it can't be them.
Yes.
Yeah.
And then I see another overlapping pattern, like the shapes, I mean. What other like recurring theme is there in this pattern? Put your answers in chat.
Yeah. What would appear in the middle?
I've seen rhombuses, tilted square hourglasses, lots of great ways to describe it. Yeah, it's like that kind of X-y pattern that like goes back and forth like that.
Yeah.
So how about we fill that in too?
Yeah. So we have these little X's here. Ooh. Two little diamonds there. And, well, at this point, only one of the answers has the two little diamonds left in there.
Right, yeah.
Yeah.
And
So, which...
it is... Yeah, what is the correct answer at this point?
Yeah. I mean, keep in mind that we have to include the corners of the squares too. So we're going a little farther than just the little thing in the middle.
Right, yeah.
Yeah.
Okay. So I'm seeing it has to be B or I will crash out. Yeah. So I also think it's B. And a lot of people in chat agree. So, Joe, do you agree?
Yeah, I agree with this.
Okay, sounds good. So, should we take a look at the correct answer?
Yeah, let's take a look.
Yes, it is B.
Yes. We had those two little diamonds. We have to have the whole diamond in there. Let's see. Do you want to move on to the next question, Leo?
Yeah, let's do it. Okay. Mike has a flyer with numbers and holes in the flaps on both sides, as shown in the picture. He folds the right flap along the dotted line and sees the numbers 2, 3, 5, and 6 through the holes. Then he also folds the left flap along the other dotted line. What is the sum of the numbers he sees now? Okay. So he folds the right flap. Let's see kind of what that looks like. I'll try and reproduce that on my screen. So you got like this 3x3 grid. And only a few of these squares are revealed. So we've got a 2 here, a 3, a 5, and a 6. Is this what you were thinking, Joe? I initially had it backwards, but I realized it had to be this side.
Yeah. I mean, when you're flipping it, it has to be mirrored so that when you're flipping the rightmost one over here, it actually goes to the leftmost spot over here. And I think we can apply this same logic to the other flip, don't you think?
I think it translates perfectly. So let me fill that one in. We've got kind of got this 4 going over from this spot up here goes into the top left corner. Okay, 4, and then right below the 4 we also have another empty spot. That would be 3. Below that is 8, and then to the right of 3, or kind of to the left on the flap, but to the right of 3 in the center part of the flyer, we'd have 5. So I think we've got all 4 of them. What do we have to do now?
Let's see. We have to see the sum of the numbers that he can still see. So it can't be covered by either of them. And I've circled in red and blue the numbers that are covered or not covered by each of the flaps. The red is the right flap, blue is the left flap. And we can see that only 3 and 5 have both the blue and red circles. So they correspond with the empty spots for both of them. So the remaining numbers should be 3 and 5. Yeah. Let's see what the question's asking for. What's the question asking for, Leo?
It wants to know the sum of the numbers he sees now when both of these flaps are shown, are both like on top of the center part of this flyer. So just 3 and 5 left. We have to find the sum. Sum of 3 and 5 is, yes, 8. So answer choice E. Makes sense to me. Should we take a look at the right answer?
I think we should. I mean, chat agrees with us, so I think we have pretty good odds of being right here.
Okay. Yes. The correct answer was E, or 8.
Okay. Let's move on.
By the way, that was a problem from the 5 and 6 level, and it was just problem 3, so one of the easier side, but it's only going to get harder from here. That said, I do believe in us. We can keep going.
Ooh. This drawing shows 3 flying arrows and 9 balloons that don't move. When an arrow hits a balloon, the balloon pops. The arrow flies farther in the same direction. how many balloons will not be hit by arrows?
Hmm. I guess, what if we gave the balloons numbers and then let people type in the chat which number balloons are going to be popped? So, how about this green one in the top is number 1. This red one in the top is number 2. This little blue one could be 3. This big other red one could be 4. And this big blue one is 5. There's a little yellow one that will be 6. And let 7 be the big yellow one. 8 can be the big green one. And 9 can be this little red one. Okay. Which ones will be popped?
Yeah.
Okay, I'm seeing 3. Joe, is 3 going to be popped?
Well, let's see. We can go for the arrows. You can see, I mean, 3 is closest to that arrow on the top right there. So if we can see which balloons it pops, we can see whether 3 gets popped or not. What do you think?
Yeah, that makes sense. So let's first follow this top arrow and see which balloons it can pop. Okay, it's flying, it's flying. It's going to hit number 1 and pop it. Okay, got that. It keeps flying, and it hits number 2, right?
Yeah.
Okay, so those 2 got popped. And it looks like 3 survived. Seems like it's in the clear, but just to be safe, let's continue by following the second arrow. How about you narrate the second arrow's path?
Yeah. The second arrow flies. It flies 4, narrowly misses 4, and then it hits balloon number 6.
Okay.
So
And it keeps going.
6 is now popped. And as it keeps going, it hits the very bottom part of balloon 5. And so 5 is also popped. And would you like to say the journey of the third arrow? Tell
Let's
the
do it.
tale.
Okay, the third arrow flies along simultaneously with the other 2 arrows. It hits near the base of balloon number 7 and pops it, letting out like a squeak kind of sound. You know when like balloons get popped?
Oh, yeah.
All right, and then it continues and it nails balloon number 9 and completely destroys that balloon. It's totally gone. And it narrowly misses balloon number 8, which somehow survives unscathed. Okay, so which balloons have survived this onslaught of arrows?
Yeah. I'm seeing in the chat someone saying 438 survive. 348 looks like it. I mean, none of them got popped. And so let's see what the question is asking. How many balloons will not be hit by arrow? I mean, there's balloon number 3, balloon number 4, and balloon number 8. And so I think that's just 3, right? What do you think?
Yeah, that's what I got also. So let's look at the answer. And lo and behold, the correct answer is 3.
Yeah.
Okay. Good job, guys. And let's go to the next problem.
Would you like to do the honors this time?
Yeah. Another arrow-based problem. This time it's about Diana, who is shooting arrows at a target. Diana first got 14 points with 2 arrows on the target, as shown on the far left. The second time she got 16 points. And the question is, how many points did she get the third time? The third time she got 2 bullseyes. And the second time she got 1 bullseye and then 1 on the outer rim. And then the first time it was 2 on the rim. Okay?
Yeah. I mean, this problem is difficult because we don't know the exact scoring system of the target yet. But let's look at the first one. We know that both of the arrows hit the same outer ring, so they must be worth the same amount of points. So how much should an arrow that hits the outer rim be worth? Put your answers in the chat. Put your ideas in the chat.
Okay, a lot of people saying 7. Some people say, just a bunch of people saying 7. Yeah, that makes sense. Because if we got 2 arrows in that like grayish area and that was worth 14, we divide by 2, as Joe is illustrating, and we would get 7. So we mark that. We got 7 in this outer area. And then we can pretty easily figure out what the bullseye is worth, right?
Yeah. I mean, we know that the shot on the outer rim plus a shot in the bullseye is equal to 16. So what should be the value for a shot in the bullseye then? Yeah, put your ideas in the chat. Oh, I see someone's already got it. Oh, a lot of people have already got it.
Wow,
Yeah.
that was fast. Okay, so people are saying it's 9. And yeah, I agree with that answer. It's 9. And then we finally have to apply our findings to this third illustration of Diana's arrow shooting. And that's 2 bullseyes. So how many would 2 bullseyes be worth if one is worth 9? Put your answers in the chat.
Yeah. Yes. Oh, I see an 18. I see another 18. Oh, wow, that's a lot of B's and 18s. The chat
Right.
seems to be in consensus. Yeah. I also think it's 18. What do you think, Leo?
I agree. It's 18. And people are saying B because answer choice B is 18. So, yeah, let's go with answer choice B. Should we check the answer?
Yeah, let's go for it. I feel very confident in the chat. And 18.
Voila. It is 18. Okay, I think we've got like 1 or 2 more problems left. So let's keep going. Oh, another obscured information problem. Okay, let's go. Joe, can you read the problem?
Sure. Alice subtracted 2 two-digit numbers. Then she painted 2 cells. What is the sum of the 2 digits in the painted cells? Well, let's see. Where should we start with this problem, Leo? What do you think?
Yeah, let's ask the chat. So I'm gonna outline a cell. It's the ones digit in this 20 something number. And I'd like the chat to tell me what digit this has to be.
Yeah. I mean, we know that this last ones digit is a 5, and this ones digit over here is a 3. So let's see in the chat. What do you think should go in this box? Oh, I see some people are saying 8. I think that makes sense, because 3 minus 8, that gives you a remainder. That gives you 5 in the next digit when you do 3 minus 8. What do you think? Where do you think we should go next with this, Leo?
Well, now that we've got that this whole number is 28, what if we added 28 to both sides of the equation? So that would look like something d3 equals 25 plus 28. And now we can just figure out what 25 plus 28 is. So chat, what is 25 plus 28? People are saying it's 53, 53, 53. Lots of 53s. Okay. And that would mean that this inked over digit would be, right, yeah, Joe's put it in already. It's 5. And so is the answer 53? I don't see any of the answer choices as 53.
Yeah. Let's look at the problem again. The sum of the 2 digits in the painted cells. So we're actually trying to find what this digit plus this digit is. And well, I mean, that's just 5 plus 8, which I'm sure the chat has been yelling at us for a long while to put in the answer as D, 13, because it's 5 plus 8. Yeah. Think we're ready to check the answers, Leo?
Let's take a look. All right, 13.
All right.
Flawless again, chat. Okay, let's go to the next problem.
Ooh, and I think this is our last problem for the day.
Wow. I'm seeing a theme here of obscured information problems. So I'll do the honors. Let me read the problem. The problem says, the picture shows the calendar of a certain month. Unfortunately, an ink spot covers most of the dates. What day is the 25th of that month? And I'd like, chat, can you help me fill in some other dates? So for example, just to warm us up, what day of the week is the 4th?
Yeah. Someone has the good observation that Tuesday is the 2nd. So if, oh, sorry, Thursday. Thursday is the 2nd. So that means Saturday, if we count forward 2 days, the chat is saying has to be the 4th.
Okay. Got it. That makes sense. And then we could just count by ones, or as I'm seeing some people in chat say, we can kind of count by sevens. Joe, how do we count by sevens?
Yeah, I mean, each week has 7 days in it. So if you take a day and you look at the date 7 days later, it should be the same day. So by that logic, when do you guys think the next, let's say, the next Thursday should be? What date should the next Thursday be? Yeah, put your ideas in the chat. What should be the date of the next Thursday?
Okay, people saying 9. So the 9th of unknown month. Okay, I'll fill it in. And then how about the next Thursday? What date would that be?
Yeah.
It comes after the 9th, kind of. People saying 16 seems right to me.
Yeah.
Okay, and then after that, what comes below that?
Let's see. Yes, the 16th is the next Thursday. Oh, someone's putting in the 23rd. I mean, yeah, we're counting by sevens. So 2 plus 7 is 9. 9 plus 7 is 16. So 16 plus 7 should go on with 23. Okay. Well, now we're pretty close to the... Oh, sorry?
I was just going to say, what if we go on again? What's 7 after 23? That would be... Joe, what would that be?
Yeah, 7 plus 23 should be 30. But that overshoots. That's over the 25th. Yeah.
Good point.
So I think we have to go back a few days. What do you think, Leo?
I don't think counting by sevens will work for us from 23 if we're just trying to get to 25. So what if we tried counting by ones again?
Yeah. I mean, we can go from Thursday to Friday, 23 to 24.
Okay, let's fill that in. So we've got Friday the 24th, and then finally the 25th is what comes after Friday.
Yeah, or as the chat has been saying, Saturday. The answer is Saturday. Yeah, that sounds about right to me, Leo. What do you think?
Yeah. And I think it shows it on your screen only, but what answer choice would Saturday be?
Answer choice of Saturday should be D. Sorry. Yes, it is D. Sorry, I just pulled up the answer slide.
Hopefully nobody saw that. Although, I realized this, the answer choices have been showing on my screen in the chat because people have been spamming D.
Yeah.
So, should we look at the answer?
I think we should. Let's confirm. And okay. It's Saturday.
All right. Flawless job today, chat. Thank you for coming. And Joe, is there anything else or can we dismiss them?
Yeah, I think that's all the problems we have for today. Yeah, thank you all for coming and anybody who is watching as well. Absolute pleasure doing this live solve with you guys. Yeah, any closing remarks from Leo?
Keep mathing. Yeah, you can find more of these types of problems online if you want more, or I guess or come back to the next live solve, which will be next month, if I remember correctly.
All these problems are Math Kangaroo problems. If you remember what he said in the beginning, I also recommend all of you to sign up for Math Kangaroo. Excellent program. I think I did it when I was younger too. What about you, Leo?
Yeah, I did Math Kangaroo also when I was their age.
Yeah. So highly recommend. I will see you all later.
Okay, bye.
Goodbye.